Okay, welcome to another school year in the fall semester, and to CS635. Usually the biggest question in first day classes is, will I be able to get in? And right, the chair right there. And the answer is basically depends upon how many of your fellow students you can convince to drop. You can convince them to drop, then it's not going to get in. As you probably all know, we've got the waitlist system. The whole point of the waitlist system is to make sure that instructors have no control over which individual student is admitted to the class, right? So instructors cannot see the waitlist. You have no idea whether you're number 1 or number 40 or in between. You also know that your waitlist is a priority based on number of factors. So you could be number 1 today, and then this evening, someone with more units decides, I want to add myself to that wait list, and they'll listen to you from. In general, we find that at the beginning of the semester, a long wait list, and they tend to dwindle so they're much smaller by the add drop date, which is September 10th. Right? Of course, that doesn't mean everyone gets in. It could just mean that we'll drop and take the name off the wait list. Now, I do have to warn people, certain automatic things happen on the wait list, right? So if you're enrolled in another class at the same time, and you're on the wait list for this course, and you get into this course, then you automatically drop from that other class. This has one side effect that makes me nervous. Come September 11th, whatever courses you're in, you are in, right? And that's it. It's virtually impossible to then change your schedule to September 11th. It can be done, but only under extreme conditions, which I guarantee you that none of you are going to have. And the problem that worries me is, some people like to wait until the last moment to decide when to drop the class, right? I've had students come to me Friday before a Monday and they're enrolled in 5 classes and they're only going to take 2. Like, well, can you just drop 1 this weekend? So that, some other students, no, I'll wait until Monday. It's like, but you know that you're going to drop 3, and there are 3 students that really like to get on those classes, and they can't until you decide to drop. So the problem is, what happens is 10 o'clock at night, and someone drops a class. Do I then add someone? That's dangerous, right? Because what happens if they are in another class at the same time, they sort of give up this class, and then I add them, they get dropped, and they wake up in the morning, email saying, oh, by the way, you're now in this course, not in that course. It could be painful for that student, right? So that last night when everyone's adding, dropping, I don't add any. It may be only 1 out of 20 students, 1 out of 50 students would happen. So what happens, it's a disaster, right? And I have no way of knowing. So I have no idea who's on the wait list, right? So I can't even check the schedule and say, oh yeah, that's okay because they're. And what happens if they're enrolled in 3 courses that don't meet this time, and they get in a class, now they're in 4 classes. Not good, right? So basically, come September 10th, after about noon, I no longer look. See for any more topics. It becomes too dangerous for me to know who's on the wait list, what the situation is. Okay, any questions about the wait list? When you go to the class schedule, it shows you the total enrollment. It shows how many are on the wait list. There are good things and bad things about the wait list. One of the bad things is, in the past, we could get rid of wait lists by saying, oh, we'll take attendance, you don't attend a class, then now, who's on the wait list? Yeah. So yeah, it's basically, there's a wait list. Some of you will get on the course, some won't. One of the problems that makes it a little harder in this class is that if you take a course on robotics, right, they can, the first lecture, they can give you a hard assignment or something that's hard, or start talking about, oh, we need to know this mathematics, and scare people away. This is mainly a design class, right? So it's harder to come up with assignments which are scary. So we have a course website, and let's see if we can do this. So here is course website. So I do things like lecture notes, right? So the slides I use, I always post before class. You can look at them. It means you don't have to take as many notes. I also record the audio and what's going on the screen. I post it later. I post assignments, so you already have an assignment which is due next week. Assignments in this class, I want hard copy instead of soft copy. All the assignments I give this class, I assume that everyone that's a graduate student can actually make work. The issues are, the assignments are, can you make this, can you meet the requirements, right? The basic question is, how do you put the program together? And I find it a little easier to do that with hard copy. Because I can circle this, write more notes. Whereas if it's electronically, then it's like, okay, I have to load, download them all, unpackage them all, and then I have to load it into IDE, and say, oh, is this language, that language is new, right? And then I open up different IDEs, and you're like, okay, I'm waiting for the files to load, So it's just easier to stack a paper, pages, mark them up. That has one bad side effect, and that is you turn them in class, right? As opposed to electronically, they have arbitrary due dates, Sunday night. So all the due dates would be the Tuesday. The other important thing I've got here, reading assignments. So I have an assignment. I have a couple articles I want you to read next time and talk about them. One is a rather famous paper called The Big Ball of Mud. It is very well known in certain circles, the publishing circle books. And then there's another short article talked about sort of the same thing. And then I'll report some other reading assignments later. And there is a syllabus which you can access through the website. And for those of you who are not enrolled in class, you can get the email. If you want to access the website, just go to www. SDSU, and then scroll down with the link towards my course information, and that gives you a page which shows you all the classes I taught for the last 1 years. I haven't set the exam date. There are some students who are taking literary courses at the same time. So I'm waiting to hear back from math instructors when their exam will be, so we can try and resolve and on different days. We will have a final, and the final will be at the time scheduled by the university, whenever that is, and look that up as well as I can. And one other thing about the websites is I have a wiki. Wikis are websites anyone can edit. And so I've got a question about the course, question about assignment 1, and there's a sandbox. And the sandbox is there so that you can just practice editing, so you don't have to worry about somehow screwing up, right? And the course to edit, when wikis first came out, people could just have unprotected wikis, which didn't work very well for obvious people started spamming them. And so to use a wiki, you need a username and a password. And SDSU, all lowercase, works as either the username or the password. And the other one is CS635.
CS also works.
Either all lowercase or all uppercase. Either one works. And of course, my browser remembered that I entered that password, so it did it automatically for me. So that's why I didn't ask for it. And then you get this window, and there's various you get a chart though, which explains various ways of doing various types of markup, and you can just edit it, right? And we can now, so let's make a heading, and then we can save it. And right, so this, and we can then look at changes. It'll show which pages have changed. I can look at the history, and it will then show me the history of each edit. So if you really do screw up, we can always go back, right, and look at the page before you screwed up the content set, right? So we can actually go back and look at various things. So, and the goal of this is, at some point you may, for instance, you might have questions you want to ask outside of class. If you send it to me by email, and it's like I answer it once, he has the same question here, and then I can email it to him, and then I get, it doesn't look very well, right? And so here, we post it on the wiki, and then I can answer it. And there are times when some other students will know the answer, and they can post it an answer. Okay? What else? That's about it for the website. Any questions so far? Yeah, I've talked about everything here except for the course portal. The only thing we use that for is I'll post your grades there so you know how you're doing. You don't need to worry about that for a couple weeks. Let's see. Languages, every semester, well, allow certain languages. And this semester, this is the set of languages. The Python is interesting in that the other languages are typed and the Python is not. And that actually changes somehow some of the patterns work we'll talk about. I'm not a fan of C++. For a couple of reasons. One is you have to worry about pointers and you have to worry about virtual, non-virtual, and then all of a sudden it's all this stuff, right? It's not pleasant. Also, yeah, you got this libraries I don't know as well. C#. The last time I did C# was at least 15 years ago. And so I don't know the libraries if they're going to be hard to grade. And given there's 60 people involved, one has to deal with reality. The whole point of this course, we'll talk about object-oriented programming. We'll have a review. We'll spend a lot of time talking about various design patterns, coupling cohesion, and do unit testing, how that works, refactoring. So these are the topics I want to talk about in this course. One of the problems we have is that scale changes everything. To write a program that's 100 lines long, you don't need to worry about all kinds of things, right? A small program, just make it work. Who cares? When the program's 100,000 lines long, you really need to think about the structure and how you put it together and how you make it, right? completely different animal. And this comes into play because as students, you can't write big programs. Look at a semester. I mean, what's the biggest program you can write? 2,000 lines, 3,000 lines, right? How many people here work professionally? 2,000 lines, does that sound like a big program? Yeah, it's nothing, right? The problem is, when you learn how to write software at university, right, you only write tiny little things. And you don't need to worry about lots and lots of things, but you do need to worry about when you write real systems, right? And that works against it. Why? Because it's like, well, I need to get this done. Now I've got this assignment, this assignment, this assignment, and I got this test. I'm taking these courses, and then I work part-time. It's like, just get it done, right? Turn it in. And you say, well, you should worry about unit testing. It's like, well, but it's small enough, I can stand test it, doesn't matter. But then you never learn how to do that, right? Use source control system, why bother? It's just one person. You never learn about that, right? So all those things you never try out, you never get good at, because you're just trying to get done, right? And then you walk out and get your first job, and like, well, source control system, right? And go, what's that? We never use that. Continuous integration, oh, we never, what? There's all these things you do in industry, worry about code quality that you don't have to worry about when you do assignment. And actually, they slow you down, right? Because, okay, you have to do this, all these things. Programs only going to be 50 lines long, so why bother? So the scale is a problem. And it works against us here. So Norris was some guy who just realized, in his career that he kept on running the barrier, right? He started writing in the beginning, it was like somewhere between 1,000 and 2,000 lines of code. It was like all of a sudden, what he was doing, it didn't work anymore. So he figured, how do I write code that's bigger than that, right? And then it was like, later it was like 10,000 lines of code. Okay, and another barrier. You had to figure out other techniques, other ways of dealing with things because it just got too big, right? Right, so this is, again, I'm going to tell my students that universities may not be a good place to become a programmer because you get assignment. How much time can an instructor spend reviewing your code? Well, there's 60 people in this class, right? Every minute I spend on an assignment is an hour. So if I spend 10 minutes per assignment, that's 10 hours. And you can't spend 10 hours doing the same thing over and over again, right? So it's not 10 hours, it's more like 12 or 13 hours break, right? And if you do code reviews, how long does that take, right? Half hour, hour? No, more than that. Right? So some remedial material, formatting, right? You want to be uniform and consistent, right? And it should show the block structure of the code. I get assignments like this. Don't do this. Right? Don't do this. Right? Go to this point. There are a couple ways this happens. One is you mix tabs and spaces. And then when you print it out, printer thinks a tab is worth more than your IE or your text editor, and so then the alignment gets all mixed up. Another way to really mess up your code is, oh, I know I'm going to put it inside Microsoft Word, and then I'll print it out. Bad idea. Really bad idea, right? Because Microsoft Word, oh, look, there's text in there. It's not spelled correctly. I'm going to change it. Oh, you forgot to capitalize a bunch of stuff. I'm going to capitalize it for you. Right? So literally, you turn assignment and reach method or function which is formatted poorly, you point. Right? Now, languages have naming conventions. You want to follow them, right? Why? Because once you follow the convention, it's easier to look at the code. You automatically know what it is, right? In Java, if it starts with a capital letter and it's not all caps, and we know it's a class name, right? Oh, okay. Automatically, your eyes just know what it is. You start changing it. Okay, what is it? Oh, he doesn't like to capitalize classes, right? He wants to capitalize his method. He's like, it just looks weird, right? So whichever language you use, follow the convention. And again, if you turn in an assignment and you've got a class, the name of the class not capitalized, better. And these are, when I get assignments, usually I say there's so many points for this, so many points for that. These points are not included, right? The other problem is that what works against us is that we, as an assignment, you get them working, you turn them in, and you get it back, and you get the grade, and you're done, right? And then you set them aside, and you go on the next assignment. That's not what happens in the real world. In the real world, when code dies, it's usually a bad thing. Because they're paying you money to write that code, right? And so the time you spent writing that code is, they just lost that money. So usually, code lives on for a long time, and that means that code is going to be read more time than it's going to be written. Which means one of your main jobs as a programmer is to write the code so someone can read it, understand it. Right? You know, the compiler doesn't care about your naming convention. It doesn't care about your names, right? As long as they're different names. A1, A2, A3, A52, doesn't matter. The compiler doesn't care. But the reader does. In general, abbreviations make it harder to read. Abbreviation fault. Just slow it down a little bit, right? You probably figure out what it says, right? But it wasn't really fast, right? Like, okay, oh, I finally got it. Here it's like, oh yeah, right? The name flag tells you almost nothing, right? It says, there's a condition I'm checking for. What condition? I don't know. How to find what the condition is? I have to read the code to see what that condition is, right? And once I know what the condition is, then I know what that flag is for. Nothing else, right? And flag status, compute flag, I mean, it doesn't help, right? It doesn't help you read the code. Oh, if found duplicate, oh, okay, that, oh. that tells us what the condition is without having to understand what comes before or after to figure out what it is, right? Names can really help you understand the code. That's two. Again, the problem when you write them, you're like, oh, S1 is for this, S2 is for that. But no one else has any idea what the difference is, right? How do we find out? We look at how you use those words, those names, right? And we go, oh, okay, finally S1 means this and S2 is that. But then the problem is you come back next week and we go, what was S1 again? I don't know. How do we find out? Oh, you have to understand the code to figure out what the names mean. So again, use names to help the reader understand, right, what code is doing. My, right? Who are you? I don't know who you are. I mean, you check the code out from the repository, and we've got 5 people on the team, and over the last 3 years, there's been 3 or 4 people left. Which one wrote that one method? I don't know, right? And it doesn't tell me what's different about your linked list from his linked list or the other linked list, right? I have no idea. How do we find out? Oh, we have to read the code to figure out what's special about your linked list. Temp is sort of a universal abbreviation, right? But it's typically used to swap two variables, right? And why not use the word swap instead of temp, right? It tells you what you're doing. And you never want to use the word temp and use it here and here and here and here. It's like, wait a minute, why is this temporary variable spanning? What's it being used for? If it's used in multiple places, it's not being used to swap, it's being used for something else. What? Don't know. How do we find out? Oh, we have to read the code.
Something that I always run up against when I'm writing code is what happens when the description of what the variable is for is especially long or unusually long. How do you typically approach that? You can't shorten it without losing semantics.
Yeah, so the question is, what happens when the meaning is long, right? The problem is having names this long, it just doesn't work very well, right? Because your code starts wrapping along. It's not an easy question to answer, right? Naming is not easy. And that's why you need to practice at it. Because how can I take this and make it, how can I describe what it is in a reasonable length, right?
We'll try putting like the first part of the variable, the class name, then the variable name.
Well, so there are various naming conventions, right? One is the Polish notation where you start abbreviating the type it is, right? So you understand the type. But in a language like Java or Swift or Kotlin that's typed, right? Usually you have variable declaration and then type and then, right? So we already know that information.
The comment clarify slightly not abbreviated. Is that the checking?
These are all good questions, and there's no clear-cut answer, right? There's no, what happens when is this name too long? Is this name too long, right? And that's something you have to practice. And generally the rule of thumb is when your code is not readable, you want to use names to make it more readable. When that's not good enough, then we start adding comments. In this case, why don't you use a modern language? We just do this, right? We don't need let the compiler generate the third variable. You know, general guidelines, naming classes, use nouns, these are things, right? They've got data and they've got state. And then the superclass is usually like a single word. Oh, it's a reader, it's a list. And then the subclasses, how do they? Array list, oh, linked list, right? String reader, file reader. It's not always possible, but you know, again, it helps you understand. Oh, it's a list, and what's special about it? Oh, it's an array. What's an array? Well, it's a particular block of memory. So it can grow. The linked list, oh, we know what that means. You know, it's a method, what does it do, right? It's an action, make it a verb. It does something, tell me what it does. It adds things, it deletes things, clears it out. It returns something, and what does it return? And there's a Boolean, returns a Boolean value, then the name should indicate that's a Boolean, right? Is empty, right? Contains, right? Is even, is odd, right? That just makes it a little easier. When you come across that message, you know, return the Boolean, you know, right? The variable, what role does that play, right? You know, stack, yeah, so again, I don't know what that, I don't understand what that's going to be used for until I understand the code. We find a name that tells us what it's going to be used for, that helps us understand the code instead of vice versa. Right, so this is you know, this should be new to anyone here, right? But I do find it, I do code from students that don't follow these rules at all. And I found that students tend to be particularly sensitive to grade. And so one way I want to make sure that you pay attention to this is you should know this as a graduate student, and if you don't do it, you'll just take off. Right? It does work. I've done the experiment a number of times where like I'll give this lecture, and then the first assignment, and I mark a bunch and just mark a few points off, and you know, spend 20 minutes ranting and raving about it afterwards. And the second assignment's like a little progress, but not much. And I've even gone to like a third assignment, right? And then the fourth assignment I take points off, and immediately it's like students swarm up with me after class, and I'll never do it again. Like, well, you know, I marked up the other assignments, and I ranted and raved like a maniac in front of class each time, and my points off was like, there's immediate progress, right? Immediate and very great progress. So these are remedial points, and normally I give, you know, I give you so many points for this, so many points for that. I don't count that here. So if I say this assignment's worth 15 points, and this is for this it, and you have 15 bad names, I'll take those 15 points off, and then I may take out more points because you didn't do the assignment right. Clear enough? Anyone want to? What's the class?
CS635.
That is a class and a course. Now, in Java or Swift or Python 3, Kotlin, what's a class?
So I suppose my understanding of it might be that it's an overlying package of sorts. That means almost super object, structured variables bound to a different function.
So you're saying a class like a template for creating an object?
Kind of like that.
And what's an object?
Then an object, I guess, would be like a digit variable. Or
Well, what you're saying is class is a template for creating an object, and an object is instance of a class. There's a certain problem with those two definitions, right?
Could a class,
you can go ahead.
could a class be defined as like a set of features and, I guess, behaviors? Keep it really high level, a set of features and behaviors that are encapsulated in a single unit. And then an object is an instance of a class created following these plans. If you want to refer to classes.
Yeah, my thoughts are a class with the object, maybe function, and variables are bound. Well, that's fancy way of saying it, Marcus, but same thing.
Yeah, so we have two different types of things, right? We have the operations, right? And we have the data that the operations work on. Characteristics. So we can say data, right? And operations, right?
The class of these has a purpose. It uses operations on it. The class of the class has all.
Right. So, so one thing is a class defines the data and operations to go together. And you want that abstraction to make sense, right? It's improvement. It's not just, I'm going to put a bunch of stuff together because using Java and so I have to have a class, all this stuff at all.
That's
Right.
the fundamental class.
Right, the fundamental core, and it contains the data and the operations that go together, right? The operations work on the data, right? So this is sort of the key to everything. Number one, right? The class defines the data and operations to go together, and you want that to make some sense, some purpose, some goal, some abstraction to represent. And then objects are just instances of class. They hold that data, and we can then call those operations on those instances, right? And so this is, basically the key point. Now we're on programming, right? We have class, operations, or some people call it state, or characteristics, right? And then operations, or whatever word you want to use, like in the form on those, on that. Right? So when you do this, right? Like, it's a data structure now, right? When we do that, you can interface or function, right? We need both. Right? Come together.
How is this thing better than other programming strategies? Why do we prefer object?
That's actually a good question. In the last maybe 5 years, if not more, functional programming is becoming more popular. You know, they claim that what they do is slightly different. Now I would say, again, I don't know, roughly 5+ years, I forget when. I'd have to actually tell you more than that. I've been doing all my private coding and functional programming just to get experience with it, to understand that question. I find that the thought process I use are very similar in the sense of, what's a class? I define my data and the operation to go on it. So I mean, functional programming is like, okay, what's my data and what operation do I want to go on? All right? I don't put them in a class. It's like, here's the data, here are the various data structures, and then here's the operations I want to perform on. So I find that the thought process is very similar. Now, the other thing that happens is, so with the functional program, people say, look, the basic data structure is a map, they often use, or a list, and they define a bunch of predefined operations that you do on a map. They come for free, whereas when you do a class, right, you have to have, although the programming language that the two languages I like the most are the two oldest ones I know, Smalltalk and Lisp. Smalltalk, object-oriented, and all the operations that you define in functional programming come on map already, right? So it's like, all those operations are special. Well, Smalltalk has them, and when I create a map, it already has them, so I don't.
What do you think about scaling it? Object-oriented is more like a modular approach to scale.
That's what people claim. So as you write code, you have to, one thing you want to think about is that actually.
Can we do that in, like, is it possible to test without much effort? Write a scalable code.
The functional people think so. And it's one thing I get to be careful of is that in this field, how would we prove that optimal programming is better than? Well, the first thing I have in mind, what we'll do is we'll take two teams, right, and give them the same project, and then see what happens, right? The problem is, how do you make sure the teams have equivalent abilities, right? And then, of course, you want the project to be sufficiently large to make sense, which means all of a sudden you're going to have to pay these people, and who's going to do that? So most of the time when people do this research, they do it on students, And so they take a class like this and they, okay, you know, I want volunteers, and then 30 of you are going to write the code in this language, and that language, and then I'm going to analyze the results, and then I'm going to write a paper, and people are going to then say, oh, that approach is better than that approach because these 30 students did a better job. Right? I don't believe that, because how do I know those students you are the same level as these students, and these students have the same understanding of that approach as these students have that approach?
Has anyone done that, by the way? On a paper like that?
Sure. And no one believes it. I think people will stop doing it. You know, look, if someone comes to a CS program and they learn Java and they've been coding for Java for several years, and I say, okay, I want you to learn Lisp, and you guys are going to write this program that you're going to write. You're like, what's going to happen? I mean, these guys, you know, it's not going to work, right? You guys are going to do terrible because you don't have the experience they do, right, in that other language. Yeah, these and the way you write the program is really different, and your thought process are different, and you don't. So, my first two programs were terrible.
In Swift, you don't put semicolons.
Right.
And so I had to get myself out of that. Making an app for
Right.
the iPhone or iPhone.
Right.
There's no semicolons.
Right.
Close it in place.
Yeah, I do find when I'm right. Actually, I use a variant of this, right, called closure. I find that I do miss one level of abstraction, right? Because what classes, right, you have, I've got classes, I can organize methods and groups, and so I've got various levels where closure gives you functions and how do you understand the greater.
How do you deal with all the print?
Not that hard. No. You can do it long enough to get over it, and then you're like, what was the problem? And really, no. There's a period whenever you learn a language which is a different type, right, where it's like, this is all weird, doesn't make any sense. And then you do it long enough, it goes away. The same thing with Lisp, right? The first time I taught Lisp course, like, oh, I printed these, students complain. And then we actually do it for a while, like, okay, well, after a while, it's like, oh, yeah, I should have printed it, so no problem. So what are the benefits of OO? Modularity, reuse. How's that a benefit?
I guess for one thing, it makes it a lot harder to inadvertently change the characteristic of the object that you're in a situation where you don't want somebody to know what's in the object, it's a whole lot easier to hide it. Check it is. Yeah, security.
Ground up many pieces in together what you actually do. And once you bring that all together, it probably is the whole idea of the course. Build all these little pieces that serves.
Yeah, you probably want to abstract as much of the actual work from the user as you can and make the calls or whatever as understandable as possible. For lack of a better way of explaining it. Right? You make it as mistake proof. Is that
process.
They build higher level abstraction. And then you use those abstractions rather than just strings in there. Security, you give them the data, right? Reuse.
The abstraction helps you to make libraries, so you don't need to understand how it works. You know that here's the interface. Third party app use that without dealing with, oh, I need a socket. You just use some library.
So libraries, reuse. Any other?
You ship out an class or something, all the features, all the data and operations that it needs built into it, so you don't, assuming that you have all of the class and turn it on, and it does what you expect it to without.
That's sort of what we mean by reuse, right? I can
Yeah.
take that.
Inheritance and polymorphism.
Are those features or events?
Yeah, both, right?
What event? What do we get from polymorphism? What's that? And what sort of benefits do they cause?
You don't have to write inheritance.
How about you dig up when you preview?
Actually, it's very hard to make all code as fast. Polymorphism is one of the reasons, right? The runtime and the C code of the compiler knows exactly what function to call. It just wrote assembly to call that function, right? In Java, when you call a method and object, the compiler doesn't know which function to call, because it has to look at the runtime, the class of the object, and then go to that class, and then climb up that inheritance to find the right function to call it.
Understand and debug, because everything is modular.
And also the
Code root. So what are the advantages of polymorphism? What benefit do we get out of that?
you can collect common. Say, example of function. Circle shape. Circle of more function. Still have defined area. Space. All these other.
And everything as per the changes is the same thing.
You could possibly modify the behavior of the program at runtime, because when polymorphism comes into play, it looks at the behavior of the object at runtime.
Rewrite.
Eliminate boilerplate.
To some degree, but one of the big advantages is said to make things at runtime behavior. So I can then, by adding a new class or a new subclass right into my system, right, change the behavior of my code without having to go inside and model line. We'll need to look at that and see that behavior, understand how it works. So what is, we got two struct and class. Is there benefit to one over the other?
Struct. You don't declare public class.
So I declared having a
operations, or just data?
but I'm talking about these two.
Oh, these two specifically.
Yeah.
This code where you use your variables. Suppose in the first example, I can use the variables only with a function, but in the second example, I can use those variables anywhere else.
Well, the usually struct, the elements are public, right? Can we just do this? Put mine. Right?
Structs.
Yeah, but
In this case, they would
that's the same, right?
be functional.
Yeah, the function is the same, right? Now, what about this?
One, so
Encapsulating the
Yeah.
data.
Yeah.
What's that?
same.
Encapsulating the data.
No, it's still the same. Getters and setters.
But
Right.
you're giving the access to
Um,
public method.
yeah, so then what makes this better than that? You say it's encapsulated, but
You can't change. Use function.
so, but I can still change it, right?
Yeah.
Functionally equals
Functionally, it's the
equals as
same.
a function, right? You would just set the struct values, right? Built in. So I'd argue that they
But in the class B case, you have the ability to not add the setter or you.
But I'm asking, I'm like, comparing these two, right?
Functionally speaking, I suppose they do the same thing, but B, obviously you have to do it a little. But all either of these things do is set values on either side. You just painted the car a different color. It's still the same.
Right? I mean, anything I can do there, I can do here, right?
And vice versa.
And vice versa, right? Again, I would say, where are the operations, right?
So I guess B is more of a true class, while A is kind of a struct class. Because B has those operations to them. Even if like it doesn't change the way you interact with either class. There that means at least theoretically.
How are they different theoretically?
Just the process that you have to go through to manipulate the data with Class B is different than Class A. I guess if I'm getting specific, you would have to, there would be more keystrokes to manipulate the values in B than there would be.
Yeah, the difference is more keystroke.
Right.
Is that good?
Generally not if you're.
Could you, how hard would it be to write a program to translate from one to the other? So I could write a program which inputted this class, and place is used, right? And then transform it into one use that, right?
You have to remove, create a program using go to that one.
Yeah, you have to take set Z and move and change it to, instead of some object dot set Z, you change it to object dot Z equals value, right? That's it.
Right.
And to go from there to there, you just take object dot Z equals to object dot set Z.
Yeah.
That's it, right?
Have this, whether or not you do the other thing. It's true. Class should abstract data and operations are.
Yeah. And what's the abstraction there?
It doesn't matter what you do. You know that you're setting X and Z and getting it.
And what's the abstraction of the class?
You don't have directly. You don't.
That's a description of what's going on, but what does the class represent? What's that?
Those are like variables and class variables.
Yeah. I mean, again, that doesn't tell me what the class is. It tells me the bits and pieces, right? What is the abstraction?
Data type.
What does the class represent, right?
Three.
What's the abstraction? Right? If I create a stack class, right? When I say stack, you go, okay, what does that mean? We know it means a data structure which contains certain operations or certain behavior. That is, right? Last in, last out, right? And there's certain operations which go pop and push and is empty, right? So that's an abstraction. It tells us what it represents without having to say, oh, there's a this. Right? We know what it is, right?
Point on the plane.
If it's a point, then what are the operations on the point?
There is no operation.
There's no operations here, right? There's getters and setters, so we don't have the operations, right?
So these are both data.
They're both just data structures, right? They're not, right? When we say the whole idea is that a class represents, right, data and operation together, and there's an abstraction, right? We can say what the class represents. It's a cube. It's a stack, right? It's a window. It's a point. But those things come with operations we perform on them, right? We can append to queue. We can take out the first element, right? We can do pop and push, right? Those abstractions tell us the class is, right? But when all you have is gets and sets, right? Any operations we have aren't here, right? Remember that point on a three-dimensional plane, well, maybe you want to convert between polar coordinates and Cartesian coordinates, right? There's various operations we want to perform on a point. They're not here. Where are they? They're someplace else. What data do those points operate on? On that data. So the data is there, and the operations are over there, right?
So again, the set is not
What's that?
the get an offer.
Well, there is one abstraction where it is, right? What can we do? What is an array?
It's
It contains elements, and what can we do with the array? We can put things in, and we can take them out, right? Oh, that's what we're doing here, right? But an array also comes with other operations, right? You may want to iterate all over them, right? So give me an iterator, right? Find them in, find them out, right? You want it sorted or not sorted, right? Those are operations on the data, but primarily an array is a container.
I guess like the difference between a setter and a getter and like a true operation is that an operation would have to manipulate or reorder or change the data somehow in
Well,
a way.
With an array, we can describe what an array is, right, at a high level. What's the abstraction? It's a container which supports these operations.
Right.
Here, there's no restriction, right? What can I? It's just three things, three data points.
One more big difference between these two would be to limit the kind of values we can set for a particular variable. That's that one. That for the left hand, we can set any value for x. Right hand side, what kind of value we expect.
I've been waiting for about 10 minutes to say that. Now, I suspect everyone in this room has created getters and setters, right? How many times after you created getters and setters have you ever gone back and restricted what the setters can do? Every time?
About
Depends on the language. Clear what type is going.
Well, I can't put a string in those either. So when she says restricted values, she's not saying, no, I can't. I'm going to put a string. It says, no, I'm going to set it so Z can only be values from 1 to 10.
I guess the difference would be that if you try to assign a value, an appropriate value up there, you know, the program will probably crash it. Whereas this one, you can validate, can't.
Well, in its current state, you'd have to add stuff.
Right. Yeah, and that's
No,
what I'm
look,
doing.
I can put any int value here, right?
Sure.
And I can put any int value there. Same. If I try to put a non-int value over there, the same thing's going to happen if I put a non-int value here.
True. You just assign the value.
Right.
In both cases, you'd have to restrict it from one.
Yeah. But my question is, how many people have ever done that?
Set.
On the left hand side, you will have to put it every time you set the value.
Right. But how many times have you done it here?
Only one.
No. How many times have you created getters and setters and then gone back and modified that function to restrict what can go in there?
We had to restrict value.
So you're trying to say, like, let's say you want to restrict to only positive. That's what that setter.
Right.
And you wouldn't have to.
When there was need.
When there's need, but most people never do it. Right?
You just change what's inside of the bracket. To change it. Still.
Right, but there's two big points here. One is there is no abstraction here, right? So any benefit we get from functional object programming, this isn't going to give it to us, right? There's no abstraction, there's no operations or somewhere else. The second thing I want to point out is people do this all the time and they never go back and ever change them, right? So to say that someone is better than that, in that case, you're like, no. If you never do it, right, that's not, right? So this is not, we're missing the operation, right? The operation somewhere else. That's the biggest point. The other point is most people never really go back, right? And yeah, we're done for the day. Don't forget you got reading assignment. I want you to read it before we come so you can carry out the intelligent conversation.